as a license arrangement with Microsoft, you will notice that they are providing you this checksum utility SHA-1 based. John, please mute yourself. Or when you want to unmute yourself, when you want to speak, you can unmute yourself. I have muted you.
Nilesh, I have a question. This is Matt. So these are two checksumming algorithms that are used, the SHA-1 and the MD5. Is that what you're saying?
That is true. There are two methods to these checksums, and they are SHA-1 and MD5. So we calculate MD5 and SHA-1 right.
Are those the most prevalent?
Most common.
Yeah.
Yes.
Okay.
Most used. There are many more methods also. You can come up with your own methods of calculating checksums, but these are the most commonly used in the industry. SHA-1 is popular. MD5 is also popular. And so I showed you both. And in fact, if you go to our virtual machine download page, which is here, you will find that I have provided both. I have provided the MD5 method of validation as well as the SHA-1 method of validation. And you can get SHA-1 and MD5 both for any binary download that you can receive from the source. Make sure that it is actually indeed in good shape. Like, for example, we'll see more examples here, right? Subscriber downloads, go to again Windows. This time maybe look at say something else like Microsoft Visio Professional with SP1. That's another big package, and so we have this package available. We can then click the details, and again you see the SHA-1 sum right there. And for every downloadable item that you expect to see from a reputed vendor, it is expected that they give you a method to validate and verify what you are getting, and whether you are getting what you're getting is actually exactly what they intended to give you, or you got something on the Pirate Bay, or you got something corrupted along the way. You get this Pirate Bay idea? Did I explain that clearly, or do you understand it already? Implicit.
Mm-hmm.
Right. So if somebody else is giving you, they may not be actually matching what the original source is giving. So it may be corrupted on the way to you, or it may be corrupted by some evil intention. So when you go to like bad sites and you find that there are lots of spyware and all other unnecessary things that you don't want in your life, you just get that because you're not trusting the source. You see where I'm coming from? Is the question is about trust. The trust you put your trust on companies that make operating systems. Right? You tend to take them for granted. So you would trust Microsoft as somebody who is giving you an operating system that you can run safely on your laptop or workstation or desktop, and that anything that they have provided, all the way from boot up sequence till it comes up with that beautiful screen, is all created by some entity that you inherently trust. Otherwise, you will not put your secret information on that machine, would you? Right. Same applies to Apple, right? Mac OS X. This computer runs OS X 10.10.3. Where did I get the operating system from? Direct from the App Store, or direct from the Mac Store, or the Apple Store. Right? We are trusting straight from the source. We trust the company. We trust the entity. Similarly, if you have something like a laptop running Ubuntu, who do you trust? You would go and check your original source, which is, here's what the thing is. This company called Canonical will give you the original source of the operating system, and this company has a digital signature verified, and you download it from that trusted site. And when you download it, after you download, you check the checksum for MD5, check the checksum for SHA-1, check both of them. Make sure that it is actually matching what they gave you and what you actually got. There may be a difference. If there is a difference, you delete that file. You don't proceed ahead. That is a fundamental way of establishing trust in exchange of binary objects on the internet. Questions? Any questions?
So when you type that in the checksum, the CD, how do you know what file you're checking for? It just pops up?
Yeah, I will show you how to do that. The way you would do that is, you see this command screen on my big screen?
Yes.
Open SSL, calculate the SHA-1. So calculate this for what? And that for what answer is provided right next to it, which is the file name. Similarly, here, MD5, calculate MD5 for what? And that for what answer is the file name. And similarly, in this example that you saw, I ran the same example. And for example, what I did was calculate the MD5 checksum, MD5 sum. There's slight difference in the way you write the command in different, but the idea is same. You have MD5 sum followed by file name.
And so you've already downloaded these files?
Yeah, you just saw.
Checking?
Yeah, you just saw me downloading it.
Okay.
You saw me like a few. I'll do it again here. Another one. Let's try this one. Utopic Unicorn. That first link, right? This one. This 32-bit 86. The first item is 1410 Utopic Unicorn Minimal CD. You see that?
Yes.
Okay. So I'm going to remove the existing mini.iso I have. I'm going to delete that file. So it's gone. And now I have this Nginx. I'm going to delete that also. So I have nothing left. In my downloads folder, I have nothing. Got it?
Yep.
Now I download something from a vendor. From a vendor in this case would be, say, for example, we are talking about the Canonical company, which is giving us open source version of Ubuntu Linux. And the version I want to get right now is this mini.iso from 1410 Utopic Unicorn. So I'm going to click on that link and say save file and say OK. When I do that, it's a very short, small 32 MB file, so it finishes very quickly. And right now it is going to finish, I hope, pretty soon. And when it does, then I can list it here on this screen. And when I list it, I should be able to then run an MD5 checksum on that file and compare it with what the origin said it is supposed to be. The origin in our case is this mini.iso. Where did I get it from? I got it from this guy. Who is this guy? This is Canonical. What are they telling me? The MD5 checksum should be this number. Understood. Wait. Let us do a math ourselves. We'll compare that math ourselves. Don't trust them for a blank download. We don't even know whether the download got correctly downloaded to our computer from their machines in South Africa. We have no idea. So we will do that checksum, MD5 sum, and then mini.iso, and run it. We got some value. We compare it with what they tell us it should be. And it seems like it is matching item by item. Do you see that?
Yep.
Item.
And where are you running that, Nilesh? Where are you running this to find that out?
This is my virtual machine that I gave you.
Okay. If that's what I was trying to figure out. Okay.
I can do it again. Hold on. Let me do it again. So clear and quit, and I'm going to quit this and make sure that you are also with me on the same page. You know, this virtual machine looks like this.
Yep.
Okay. You open terminal on one hand.
Perfect. That's what I didn't see you do. Okay. Perfect.
And Firefox on the other hand. And then on the Firefox, you right-click and paste the link I gave you in your Slack chat. Then you scroll down and you download this 32-bit Utopic Unicorn Minimal CD.
Yep.
Download folder. And we got that. We have it here. And I'm going to now do an open SSL SHA-1 mini.iso. And let's calculate the SHA-1 checksum and match it with what Ubuntu tells us. What do we get here? And what do we see here? Matching.
Yep.
And this match is critical. And when you write something that is automatic, you know, most checksum verifications are automated. But I'm just bringing this point to your attention is that this is a very critical step that you should not miss, because ultimately this is the root of trust of any operating system. You need to trust the OS vendor. You have decided to trust Microsoft because I don't know, you trust them, right? You know, trust is something that you know and like and trust. So you trust them, fine. You get Windows, you use it, beautiful. You seem to trust, you know, Apple Computer, which gives you Mac OS. You seem to trust Sun Microsystems for Solaris. You seem to trust Linux forwards for Linux kernel. And so all these basic origins or roots of trust begins from the operating system itself. If that operating system is corrupt to begin with, no amount of antivirus can fix it. No amount of antivirus can fix it. It actually goes one step even below the OS, and that is the boot setup. Like in Macintosh, the process of booting is called UEFI, EFI-based Extensible Firmware Interface. That is also signed by the machine manufacturer. So the Macintosh machines are signed by Apple in their unified boot interface, which is Extensible Firmware Interface. So this EFI that you have, which is EFI Mac, this thing is the firmware on the Macintosh machines that is signed by Mac, signed by Apple on the hardware level. So anytime it boots, it will look for a valid, genuine macOS DVD or a CD or USB stick for its signature, and the signature basically is similar to this concept of MD5 or SHA-1 or some other type of signature. It will validate that and only then start setting up the OS. If that setup validation fails, it will fail to set up the OS, and that's a good thing, because we don't want unknown or untrusted pieces of software on our laptop believing that they are all good. So the root of trust begins with hardware, with EFI, like in case of Mac. And in case of Windows, there is a new thing called UEFI that started with Windows 8 and beyond. Windows 7 does not have it. So Windows 8-based machines will have this method of verifying security and trust on the hardware layer. And when you run something that is designed for Windows 8 or later, it will know what you're doing. It will understand that this is a DVD issued by Microsoft, and only then it will set up. Otherwise, it will refuse to set Windows up, which is a good thing. And so that's how trust is being established at the ground level. So we are talking about security today. The theme today is about security, about trust, about validation, about verification, about remote connection, about creating keys, key pairs, connecting to remote computers. That's what we are discussing today. And our primary idea right now that we're discussing is that trust begins at the hardware layer from this concept of UEFI in Windows or this concept of EFI in Mac. Now you would say, how would you run Linux on a PC then? That's a good question. You know, if these machines are expecting to run Mac OS, they would not run any other OS. How do they then run Linux on a PC? So Linux manufacturers or Linux OS vendors have actually taken a certificate from Microsoft, allowing them, enabling them to run on UEFI-based hardware. So Microsoft has issued a certificate so that if you are running Linux on our boxes, it's okay if you are really you or not somebody else pretending to be you. You got the point?
Yep.
So that's fundamental to hardware security. Up on top, you get comes to the concept of the operating system itself. You have a variety of choices at the OS level. You got Windows, you got Windows Server, you got Linux, you know, all types of Linux machines. Multiple companies prepare and produce their own distributions. Then you have Mac OS. Then you have Solaris, and then there are new OSs keep coming. All these vendors, people trust them to begin with. If you don't trust the OS, you don't go any step further. You just stop right there. You got that point clear?
Yes.
And you understand this through the method of verification, like we did in 2 examples of MD5 and SHA-1, like I showed you in this case where we are this one. We are testing the MD5 and SHA-1 like this. Any questions on this before we jump to the next topic?
Just that my VirtualBox doesn't look like your VirtualBox.
Can you show me what you see?
Yes.
Click on the green button and see what you show. So that'll help me understand.
Okay. And then I click on that, and then it looks like that. My,
Yeah, I want to see your desktop, which is what you're showing right now. So can you minimize my window here and show me your VirtualBox on the front?
yeah. When I pull it up, this is what it looks like right here.
Okay, let's see what you got. So yeah, in here, there's a green button called Start. And you have to start machine. So this is like a virtual machine. You start it, and then it will actually boot up to look like a computer. And so allow it to boot. It takes 10 seconds. And when it does, it will start the virtual machine itself. And so maybe you want to press enter at this moment on the, yeah, that's how it proceeds. So it will proceed forward, and then it will look like what I have, which is, you know, all that that you already saw.
Okay, it'll boot up and it'll show it.
Yeah, exactly. It should take a few more seconds and it will boot up and be all ready. You should click on those blue crosses and proceed. So it will help you see what's going on in the background. And maybe press enter a little bit. And there it is, starting up soon. So you should be able to see.
Okay.
You can start up, shut down, do the whole 9 yards, just like you do with a real computer. This is a computer. It will do every single thing. And you know why? Can you tell me the reason why we are using a virtual machine like this? Like, what's the fundamental reason?
There's a reason.
The reason that I have in mind, there are two. First reason is I don't want to disturb your desktop, your laptop, whatever you have. I want to keep it the way it was. Keep it clean, keep it pristine, keep it like a garden, right? We don't want to mess. I do not want to create any mess in your computer. So what I'm essentially is give you a separate machine so that you get to play with it in like a sandbox. You know what a sandbox is?
Yeah.
And so you think of your laptop as a garden, and there's a sandbox in between. You play inside the sandbox, make mess, no problem. Don't go outside the sandbox, and you're okay. When you're done, you just remove the sandbox and discard it. And then your garden is all back good, right? So it's a place for us to play around, place for us to make mistakes, place for us to learn.
Okay.
And that's how we intend to use this virtual machine, is for us to practice. Because when we practice, we'll make mistakes, and I don't want to mess up your machine.
Yeah.
So I want to mess only inside this machine, and so it's okay to do whatever you want. You cannot hurt yourself. That's one. The second one, some of you are using Mac and some others are using Windows, and so this one gives everybody the same exact combination of software, drivers, libraries, all things, tools that I have set up already prepared for you. So you don't have to waste time in setting up things. You have already done the work for you. You just use it, and then when you understand it, you can create your own virtual machine like this. It's not a big deal. Not a big deal at all.
Okay. Yep.
Those are two reasons why we have this virtual machine that we are using right now, that you have downloaded and now ready. So having understood that, and having understood this aspect of establishing and securing trust, what I want to do next is this next idea, which is, let me see if somebody else is also waiting for us to have them join in. There is at least one person that was pinging me on the side.
Anil was trying to dial it.
Anil has connected, is he? Hey, Anil? Anil and Chris are having problems with their control. Let me see. I think Anil and Chris, let's invite them. Okay. So I'm going to invite Chris and Anil one more time. And there we go. So I'm going to stop presenting, invite Chris and invite Anil. And let's see if they are able to join. Okay, I don't see Anil yet on the. Please look for an email and join through that one, that link. Okay.
Chris is joined.
Hey, Chris.
Much
Okay.
better. Thank you. Bye, guys. Hi, everyone. Sorry I'm late.
No worries. I think it will be good if we, understand one couple of things. I think some of us established our own different hangout, different from this hangout. So you were hanging out without me at some point. Before, like, almost at 5:50 or so, it's better if you can just come in online ahead of time, a little bit, like 5 to 10 minutes ahead of time. It'll help us in getting started on time. I think that'll help. And the second idea is, please do not start your own hangout. Look for an email that says incoming video call from Nilesh, and then click through that. That's how you can participate. Otherwise, what you will see is that the event is not started yet, or maybe it is being broadcast and you can just remotely watch, but that's not what you are here for. You are here to participate, right?
Hi, everyone. Sorry I'm late.
I'm sorry.
Hey, no worries. So, good. And just one couple of things. I think some of us established our own different hangout, different from this hangout. So you were hanging out without me at some point. So, before, like, almost at 5:50 or so, it's better if you can just come in online ahead of time, a little bit, like 5 to 10 minutes ahead of time. It'll help us in getting started on time. I think that'll help. And the second idea is, please do not start your own hangout. Look for an email that says incoming video call from Nilesh, and then click through that. That's how you can participate. Otherwise, what you will see is that the event is not started yet, or maybe it is being broadcast and you can just remotely watch, but that's not what you are here for. You are here to participate, right?
Hi, everyone. Sorry I'm late.
I'm sorry.
Wow.
We will take care, Nilesh. Thank you.
And just one thing. I think some of us established our own different hangout, different from this hangout.
Is there a replay going on?
So, screen up and we've got a delay.
It's better if you can just come in online ahead of time, a little bit, like 5 to 10 minutes ahead of time. It'll help us in getting started on time. I think that'll help. And the second idea is, please do not start your own hangout. Look for an email that says incoming video call from Nilesh, and then click through that. That's how you can participate. Otherwise, what you will see is that the event is not started yet, or maybe it is being broadcast and you can just remotely watch, but that's not what you are here for. You are participating, right?
We will take care, Nilesh. Thank you.
We got the message loud and clear, Nilesh, 3 times.
I know. This is weird. Really weird.
No, you've got there's an extra screen. Someone has an extra screen open, and you're getting a delay. Probably there's still a YouTube. Somebody's got a YouTube still open.
I know.
Google Hangout.
So, are you? By the way, are we real time? Can you tell me how many fingers I have?
Yeah, 5.
No, he's only got 4. A thumb is not.
Oh.
No, he's frozen.
Frozen. Oh.
So just check to see if you've got a YouTube link, and if you have, close the YouTube. There should only be Google plus Hangout. In the meantime, Nilesh is just frozen in space and time. How did you do that? It's either that or he's practicing a very unique martial art.
I think I had one of those open and I shut it down.
One quick fallback idea. If
You just froze.
I know, I just froze, but I think I'm not frozen now.
Okay.
Right.
Yeah. So if something goes wrong, please chat on Slack. And if something goes wrong, like seriously, we'll start a different Hangout with a different name. Right now, the Hangout is number 2 out of 8, Tech 2 out of 8. We'll start a new one. If something seriously goes wrong, wait for Slack and chat on Slack if something dramatically goes wrong. Let us now jump to the second topic I want to discuss, which is about concept of establishing secure connections with remote computers. So how many of you have already connected to a remote machine somewhere? What methods do you currently use?
SSH.
SSH is one. What other method do you have to connect to a remote computer apart from SSH?
Remote terminal.
Yeah. VPC, VPN.
Remote desktop, remote terminal, Citrix, bunch of other tools are available, right?
WebEx. Mm-hmm.
Yep. So the idea that I'm going to describe right now is this idea that I will actually show in form of a paper and pen. That I'm grabbing my paper and pen tool so I can draw the concept and make sure that I'm articulate and clear about it. So I'm grabbing my laptop closer to me, attaching a keyboard on which I can write, a tablet on which I can write, and starting my software which will allow me to write. And so in that software you see there's a little white sheet of paper and a pen coming up. Now the couple of things that I would like to describe to you is when you are a user and you want to connect to another computer somewhere away from you, you use one of the channels that we will use. This is called SSH. How many of you are familiar with this idea of using public and private key pairs already? So this concept of a key pair, which is a security mechanism to enable and ensure trust on the internet. So I'm going to show you my desktop, and I hope you are able to see my desktop in a moment. Starting up now. You should be able to see my desktop where I'm sharing my whiteboard, in which you have a user, which is you, who's trying to connect a computer away from you. This is a remote location, and we use this tool to connect. But how many of you are already familiar with this idea or the notion of a key pair or a secure key pair?
Yes.
I'm not.
Okay. So the method that I'm going to describe to you is this idea of a secure key pair is conceptually similar to what you have in real life. You have a concept of a lock and a key, right, of some sort. This is a bad drawing, but you get the idea. You have a lock and a key combination. If you have the key, you can open the lock. If you don't have the key, you cannot open the lock. So it's a pair. Key and a lock are a combination. It's a pair. You get that point, right?
Yes.
Similar to that, almost very similar to that, is this idea of a key pair, where you have a private key and a public key. And this public key is conceptually analogous to the lock itself. And the private key is conceptually analogous to the key that you carry in your hand to open a door. Now, where do you get this lock and key? In India, you go to Aligarh. I'm just kidding. That's where most of the locks are manufactured and keys are manufactured. But in our computer, you actually create a key pair. You can generate a key pair yourself. And you do that by running a command called ssh-keygen, and that's the command I want to run next. So what I will do is go to my virtual machine. Close this Firefox browser. I don't need it anymore right now. And on that workstation, I have this terminal open, which is this piece of software that I start from this black window. And then I have the terminal up and running. In that terminal location, I will type this command ssh key gen. And when I type, it will produce the key pair for me. Right?
Yes.
And these key pairs get stored in a folder called .ssh. In that location where you have these key pairs stored. So these are some older keys. I'm going to get rid of all of them, just so you don't confuse yourself. So I'm going to kill all these keys first before I start discussing and showing you an example. So what I'm doing right now is killing out all these older keys and cleaning up the folder, and I have nothing in that folder. Now, having done that, I'll go back to beginning. SSH key gen. This software generates a key pair, and that key pair gets stored in this location where we have nothing yet. The location is called .ssh. It's in your home location. What is your home location? What is your username? Your username is user. And this is your home location, home/user. That's your home location. So when you type pwd, it shows you your current location, a present working directory location, pwd. When you go to cd tilde, tilde is the representation of home. So you go home. And what is the current directory now? It is your home location, which happens to be home/username. And in this case, the username is user. So it shows you the home location. Inside that folder is this folder called .ssh, which is where the keys are getting saved. Right now, we have not done anything yet. Now we'll do it first time. SSH dash keygen. And when we run it, we have a question for us. That it is generating a private and public key pair for us. Where do you want to save it? And the answer is, no, if you just press enter, it will save it in the location which is your home user folder, and then .ssh subfolder, and we'll use this name called IDRSA. That's a default setting, and that's where it gets saved. So when you just press enter, you don't have to take notes, by the way. Anytime if I describe some concept, I don't want you to taking notes, because these notes are already available on this site, which you may have seen by now. If not, I would like you to go and see that these notes and these videos are custom made for you already. And so there are lots and lots of videos available for you to watch on your own. These are short 1 minute, 2 minute segments that you can watch on your own, as you can see on this Cloud Genius website that I was showing you. I'll go and show it to you again. On this site, when you click on the security and trust button, you should be able to see the video segments and video clips already for you, lots of them. Now, having described that, I will get back to what we were doing on this, which is creating a public and private key pair. When you create a public and private key pair and just press enter at this moment, it will automatically create a folder by the default name and put the key pair in that default folder. And so we will hit enter.
You're not sharing your, Nilesh, you're not sharing your screen anymore. We can't see it.
Thank you for pointing. I will go back and make sure that I share my screen. I was sharing, but it stopped sharing for some reason. Okay, presenting again, sharing again. And then I'm back in that location where I'm sharing my screen and I'm typing the SSH keygen command.
Okay.
And in that location, I'm going to just press enter. When I press enter, it is asking me for the next question, which is, what is the passphrase do you want to use? And in the passphrase, I'll say, you know what, nothing for now. To begin with, I don't want to use a passphrase. I'll go without one. So I'll go next and enter again to go without a passphrase. And then we have a key pair ready for our use. You see that the key pair has a fingerprint that they have given us. And that's the fingerprint. And that's the name for the user at workstation, is the name for the key pair itself as a comment that you will see. Now, it told us that the identification or the key pair has been saved in this location, which is SSH folder, and the identification is the private key is stored in this file. The public key has been stored in the idrsa.pub file. Let's go inside that folder. So we'll go cd.ssh and then find out what files do we have. And as you expected, there are two files here. One is the pub private key, and the other, the .pub, is the public key. You will also notice that the permissions for the private key are all read and write just for you, and nothing for anybody else. No group members, no other people. Nobody else can read or write the private key. Only you can read. Only you can modify. Permission setting is available right here. The public key, on the other hand, is readable by other people, and so we can read it. I'm going to open that idrsa.pub file and show you how the key actually looks like. And this is the public key. Let's also look at the private key, how it looks like. So the private key, as you would know, is not supposed to be shared with anybody. It is supposed to be private. But I'm sharing with you, just so you know. No big deal. But I want you to make sure that this is never supposed to be shared. If you share this, what happens?
Compromised.
Compromise, right? You probably, some kind of issue will happen. It is almost similar to this idea where you don't share private information. So this is the private key that I'm going to share with you, and since I'm going to share it with you, I'm going to delete the key. I'm not going to use it. So that's a security principle again. However, having said that, I'm going to open that private key, and this is how it looks like. It's a fairly long entry. Begins with the begin statement. Begins with this line here, all the way to the end. All of that is the private key. Up on top is the public key, relatively smaller. Now, these two items that you look at right now are conceptually similar to a lock and a key in physical life, in real life. You have the key in your hand, you can open the lock, open the door. Now, in order for you to rent a new home or rent a new rental car from the Hertz Motor Company, what would you be thinking? Is there, Hertz Motor Company, I know I like your cars and I would rent them, but you know what? Before you give that car to me, I would like to use my own lock and my own key. So here's a lock. Please put that on your car and then I'll take it. That's the idea. You see where I'm going with it? Is that I want to give this public key to a cloud company and have them install it on the machines that they will give me, so that when I enter with my private key, that I should be able to get in, and nobody else should, because that machine has my lock there. So it is similar to this Hertz rental car company saying, you know what, I want that new car you have, the Ford car that I was looking to rent from you, but you know what, before I rent, take this lock, put it on the car for me, so I can, use my key. That's the idea. That's exactly what we'll do next, is take our public key that you see highlighted on the top and go to a cloud company. So I'm going to copy that public key right now. The key begins from that point all the way to this point. So I'll copy that whole segment beginning from the SSH, RSA. This is the algorithm used for creating the key, RSA, and the key ends all the way up to this point. Remember, that's the point where the key actually ends. This user at workstation is just an identifier. So I'm going to include the identifier also and grab the whole key, copy it like this. So I have the key copied in my buffer. Next, what I want to do is go to a cloud company, like a Hertz rental car company, and hey, give me a car for me to rent. And by the way, before you give me the car, I want to put my lock there. And so that's exactly what I will do right now. I will go to a company, ask them to give me some computers. And so here is the company. And the company is called DigitalOcean. In there, I will go log in. And when I log in, I will then ask them, you know what, please give me a machine. And by the way, when you do that, put my lock there, so I can then get in. How do I tell them this? I have to go to the settings area and then go to security segment. And by the way, I seem to have an older lock. I will delete that older lock, and so it's not there at all. And I have nothing there at all. So I have no lock there. I will now add an SSH key. So I'm basically telling this company to put my lock on the machines that they will give me. And so here it goes. ID_RSA.pub is the name I want to use. And then paste my key. And then I'll click the green button to create it. And when I do that, I have added my public key to that company. So the company knows that, that's the lock they want to use when they want to drive the car. Good. So they know my public key now. And I am going to now ask them to give me a computer on rent. This company prefers to call servers or machines or instances. They call them droplets. You can come up with your own name. It doesn't matter. At the end of the day, these are the machines that we talked about the last time. Virtual machines, like VirtualBox virtual machines. Like you have a bigger computer, you partition them into smaller computers, and you use them on rent. That's exactly what we are going to do by clicking the green button to create a droplet. By the way, do you have an account already with these guys?
Yep.
Okay. So here we are going to create a droplet. We'll call it Cloud Genius. How about that? And then select a size. I'll select a $5 droplet. That's good enough for now. It's not a big workload, so I'm just putting some basic tests. And I will select that to be in San Francisco, which is the closest to me. And then scroll down, select an operating system I want, which is Ubuntu, which is good. There are multiple other operating system choices, by the way, so you can select any one you like. And then I have to tell them, what? I want to use this lock. And so please use that one. So that I can use my private key and get in. And so I'm going to create a droplet while telling them, please use my lock. And they are going to start creating the machine in 30 seconds, and the machine will be ready. In the meanwhile, what I will do is, on my terminal, come out of that .ssh, which is not where I'm supposed to be. I should not be in that location. I should be in my home location, or any other location, but not that folder. You don't work in that .ssh folder. You do not work here. That's where you store keys. You don't work there. And by the way, there are only two files right now. The two files are the private key and the public key. Only two files right now. We understand that. We are going to come out of it and work somewhere else, like our home location. Now in here, what I intend to do is type the command to connect to that remote computer which is getting created right now. It's creating a droplet. So we want to type the command SSH and then pass the private key to this command. How do we pass it? By typing -I option and then pass the actual location of the file, which is the private key, this one. And then type in the username for the user in the remote computer, followed by @ and this followed by the IP address for the remote machine. So whatever that IP address that these guys are going to give us, we'll use that IP address in here. And then we should be able to get in to that remote computer. Now watch that happening as soon as this droplet becomes ready. And so droplet, we have an IP address now. We are going to grab that IP address, copy it. But you know what? It is still new. It is not active yet. So we have to wait for it to come online and active and ready for us to connect. Now, this company, DigitalOcean, has a promised guarantee of 55 seconds to start a new droplet, and they just failed that promise. But we understand. So we will go, and they're still creating a droplet, which is kind of unfortunate. But as soon as the thing gets created, we should be able to type this and put in our IP address at the end, and then attempt to connect to it. Right now, the attempt will be futile because the machine is not ready yet. It is still getting created. I think we have some glitch. So I'm going to create a different droplet. I'm going to ignore the San Francisco region. I'm going to go this time to Germany. So I'm going to go to German machine. I'm selecting German because it is a new region that DigitalOcean has, and that is not so heavily used. San Francisco is heavily loaded, and that may be the reason why it sometimes gives a little bit of time to set up a machine. So I'm going to go to German machine and create a machine in Frankfurt. And that's the same decision here again, but is this time instead of San Francisco, I'm going to select Frankfurt and proceed to select an Ubuntu machine and use my same key that I have, the same key. And then I'll ask to create a droplet. This will start a new droplet, but this time in German location. And hope this one finishes faster. Let's see which one does. And so right now we have both machines are new, and I'm expecting that this Frankfurt-based machine will get created faster than the San Francisco-based machine, I hope. And when it does, we'll select the correct IP address and put that one here as soon as the machines become ready, and use that one instead. In the meanwhile, I suggest you should also start a machine, a droplet, on your own and have your own public key provided to that company so that you can play along these exercises with me as we proceed. Let's see what do we have right now. Do we have any machines active? No. Wow. Wow. That is scary. This happens occasionally when you break the promise. DigitalOcean says that they promised the machine in 55 seconds or less, but did not happen. Occasionally it is cloud, right? Cloud is unpredictable, as you know, and so that's the hard thing. You are basically, it's like waiting online for a hard land. Oh, by the way, that German machine became active, so that's good. Let's see what about San Francisco. Both are active. Nice. We'll run both of them, by the way. We'll begin one of them. We'll take the IP address for the San Francisco-based machine first and paste it here. Right? So what we are doing is SSH-I and then pass the parameter that includes our private key followed by root at IP address. Do you see this line here? That's what we are dealing with. And as soon as I press enter on that command, it will ask us some questions. The fundamental question it is asking me is, hey Nilesh, do you know what you're doing? That's exactly the question. Do you know what you're doing? If you read that carefully, it says, I don't know what you're doing. Do you know what you're doing? That's the question. And the question is, are you sure you want to continue? Do you know these guys? Do you want to connect to them? And they have given me a fingerprint. And that fingerprint matches my public key. So I know that this is the same thing I gave them. And so I have to say yes because I actually know what I'm doing. And when I do that, what will happen? That this machine, my virtual machine, my VirtualBox CloudGenius workstation, what this will do is mark that machine with IP address in San Francisco, that one. It will mark that machine as a known host. So we'll say yes to it and proceed. And it did something. What did it do? It said permanently added this IP address to the list of known hosts. And by the way, it also connected. It connected to the remote computer right now. So we can see that it is connected to the San Francisco computer called CloudGenius. You can see from the command line. You can also check the IP address. Right?
Yeah.
Let's come out of it. And now go check the .ssh folder again. What do we have here? We have a new file there. What contain? The file is called known host. It contains a hash corresponding to the machine we connected to. So now we know that machine, we know that computer already. And so next time when I try to connect the same computer, it did not prompt me the question, hey Nilesh, do you know what you're doing? It did not ask me that because it knows that I know what I'm doing. By adding the line, this one, to the list of known hosts. Now if I, for example, come out of it and try to connect to the other IP address, which is the German machine. I'm going to copy that IP address and then remove the San Francisco address and instead paste the IP address for the German machine and then enter. What do you expect? It'll ask me the same question. Hey, Nilesh, do you know what you're doing? And yes, I know what I'm doing because I know exactly what I'm doing is I'm trying to connect to the Frankfurt machine this time. And so if I say yes to it, what will it do? It will add another entry to that file, the known host file. Just like this entry, one more entry becomes added to the known host file. And it says that I have added this line to the known host file. A hash corresponding to this IP address has been added to this file. So as soon as we connect, we did, to the German machine. And now I'm going to come out of it and then type my known host file and see that there are two entries now. One corresponding to the second computer, the German one, and the first one corresponding to the San Francisco one. The two entries in the known host file indicate basically that I can connect to the German machine with no problem, no question, no password, no nothing, and also to the San Francisco machine. Sorry, this is the German, and the other one was the San Francisco machine, which is this one. And so I connected to the San Francisco machine as well as the German machine, no problem, without a prompt, without a hassle, without a password, because I have a private key and I have told this company, the rental company, to put my lock in the machine they gave me. Now, any questions on this point?
No, that was good.
Okay, let's go to the next idea here, which is on this remote computer that I'm connected to, the San Francisco machine, we'll go to the SSH folder inside that machine. And what do we see there? It's a file called authorized keys. What does it contain?
Public key.
Contains our public key, but that was who was that? Who just said? Kiran. Okay. It contains our public key, right? So we gave this public key to these guys in the control panel here, and it put that authorized key. We gave it them in the security tab, and that's the hash for that key. And so what we would do now is come out of that, then connect to the other computer, which is the German machine, and we'll say the same thing over there, same exact thing. So cd.ssh and cat authorized keys, and you'll find the same thing over there. The same exact key is also placed on the same box in the same location. And so this idea of what I'm going to describe you like this is this concept which is coming up. With this concept, right? We have this thing called the file called known hosts, and this is containing a list of all the hosts that we know and trust, as opposed to this file, which is the authorized keys file, and this contains a list of all the keys that are authorized to connect to that machine. And so if you want to add one more key, just like we have two computers with one key, we can do this other experiment, which is, I'm going to come out of the German machine, back in my main computer, in my .ssh folder, I have only one key, which is a one key pair, which is this one. This is the key pair I have. And I have two machines here, one of them in San Francisco, one of them in Germany. Good. Now I'm going to create another key pair. How would you do that?
Keygen.
SSH keygen and enter. And this time it is asking me the same question. Hey, where do you want to save it? And so this time I'm not going to just press enter, but instead I'll give it a different name. Like different, for example. and then it'll ask me for a passphrase, and I'll say, you know what, no passphrase for now. Just move. And it created a fingerprint as well as a key pair called different. And the private key is this one, and the public key is this one.
Hey Neelesh, if you hadn't named it different, would it have overwritten the previous key?
Class.
It's a very good question. Let us run that command again and see what happens. And this time, I'm going to say boom. And see what happens.
It says it already exists. Okay.
Yeah, asking me, do you want to overwrite it? Yes or no?
Okay.
And so it will not blindly overwrite something, but ask you. And if you say yes, it's obvious, right?
Yep.
Yeah, yes or no is obvious. So I'm going to say no for no reason. I don't want to destroy. So we have a key pair. We call this one different. The original one is called ID RSA, and that's all good. Now I want to use these two key pairs are kind of, you know, a possibility. You can have multiple key pairs. Nothing wrong with that. It's just a matter of convenience to use one key, and one key operates on the San Francisco machine as well as the German machine, and that's a common individual developer scenario. In larger corporations, you will have multiple keys and a method of rotating your keys every month, every week, every quarter, depending on whatever frequency you want. And you can rotate, meaning change your keys every so often, depending on your company policy. And that's also a good security measure. You know what? You have heard of this thing called Sony PlayStation 2 hack?
Mm-hmm.
Where everybody who's on the PlayStation Network, their private somebody's open on mic. Somebody just changed the mic settings and it's causing echo. I hope not. So the thing I was describing is the Sony PlayStation Network. All that private information about all PlayStation members, including their social security numbers, credit card numbers, and their address was all leaked out and available as a download on Pirate Bay. How did that happen? Was it a security leak? Was it because it was a public cloud or private cloud? None of that. None of that. It was a human mistake. The human mistake was as simple as some idiot managed to lose the private key. And you know how that happens. You know, you just be not careful with the private key and you let it go, and then what? What happens after that? You know, anybody can access it. I mean, you don't require anything else apart from the private key to get in. And that's a security hole. So, you know, private keys are so protected heavily. It's almost to the extent where larger companies manage their keys so that any individual cannot even visually see the key. They can only use it. So imagine this scenario. You go to a bank and you put your jewelry in there, right? Sometimes, you know, some people, wealthy people do that. You take your jewelry and go to a bank and keep in a safe deposit locker. Have you seen such a thing?
Mm-hmm.
When you go there, the bank officer goes along with you into the chambers, and they have a key, and you have a key, and it's a double key open method. Only one key cannot open the locker. You need both keys, the bank officer's key and your key, and then the lock opens. You've seen that scenario, right?
Yep.
Similar to that, with shared responsibility put in place in larger companies to manage key infrastructure. Conceptually similar to that. And so if you lose the key like this, you know, it can cause disaster. Literally disaster. You know, I can demonstrate that example by, you know, maybe giving you my key, and it will let you connect to these two machines I have comfortably. How would you do that? I give you my private key. You put that in the command in the terminal, just like this. You see at the bottom here, pass that file just like this, and then you can, from your location, connect to my machines in San Francisco or in Germany. It doesn't matter. As long as you have that key that I have highlighted at the bottom of the screen, you can comfortably connect, and it will let you in, because that's the key to the kingdom, in effect. Right?
Right.
Now, we have the second key, like this public key, this different key. And I want to be able to use that as well. How do I do that? What should I be doing if I want to take that different key and then use that different key, because I want to now rotate. I want to retire the ID RSA older key, and I don't want it anymore. And this retirement of keys and rotating them every so often is a concept that is important. It's almost analogous to the idea of you taking a shower every day and changing your undergarments.
Oh, that's a bit too personal.
Yeah. Yeah. But that's the idea, right? You have to do that. If you don't do that, what happens? The similar thing happens in this context, right? You get some things wrong, and so you rotate your keys. And so we are going to rotate a key by hand. What would it take for us to rotate the keys in these two machines? Can you tell me? What would be the mechanics of key rotation when you want to change something?
Change the public key.
Yeah, change the public key. Where?
In the servers, hosted servers, I mean,
That's
you
right.
have to put another public key there, and then probably you'll have to have some mechanism of making them active by some mechanism.
Right. So here we have this. Anil, I think you have to close. After you're done speaking, please mute. That will help, Anil. So the different key that we have here, which is the different.pub, that key. If you have to use the different key, then we have to copy this item. Go to the remote computer. This one is the German computer. So we'll go there. And then to that file called authorized keys. This one. And this key is the IDRSA key, the public key. You have to remove this key and put the different key in place. And so we'll do exactly that. We'll go modify the file, delete that line, import and put our line, that this is the different key, and I'm going to save it. Now I just swapped my old key for the new one. Now this is a deadly action. If I make a mistake, I am logged off my own machine. So
Yes.
don't do that. So this is not how you should do, by the way. So what's the workaround? Workaround is to test before you lock yourself out. What I just did is the wrong way of doing it. So I'm just highlighting these ideas because you want to be able to recover from a disaster, and so you don't just delete an existing key without testing a new one. So what do? You not only have your old key, but also have your new key together at the same time. So in a separate terminal, what I will do is cat my IDRSA.pub also, copy that, and go in here and paste that as well. So now I have two keys, both of them in the authorized keys file. And now, since I have both keys in place, I should be able to use any of the two keys and then use any one of them. Now I know that I have just added both keys to the German server. Now this time I'm going to modify the key itself. Instead of using the IDRSA, I will use the different key and then see if it lets me in. And it did. Good. Now I know that it is able to work with my new key, which means I can now safely afford to delete the older key. And so now I'll go back to our SSH folder in the remote computer and then edit the authorized keys. And then the second key that I have is the older key. I'm deleting that and coming out of it and coming out of breaking the connection, going back in with a different key in, and it should let me in. And it did. Now I'll come out. Try my older key this time with the German computer, and it will not let me in because I have rotated my keys. It did let me in. How did it let me in? Crazy. I thought I deleted it, didn't I?
Yes.
You saw me deleting that one, right?
Yes. Was it still cached? Cached.
Probably caching. Probably caching. Maybe a server reboot is needed. So I'm going to reboot, not the server reboot, just the SSH daemon process needs to be rebooted.
Yeah. Stop and restart the SSH CD.
Yeah.
For good measure, you could always stop and start the Ethernet port or the network ports, couldn't you? The network service.
That also works. So what I'm going to do is on that remote machine, the German machine, I'm going to just for ease, I'm going to reboot the machine there, reboot, and come out of it. And it just came out. So the next time we should be able to use only the new key that we have, and we have effectively retired our old key from the German computer. That's how you rotate keys manually. Of course, there are softwares and there are automated methods that you should apply. And anytime you are changing keys or modifying something, I would like you to rotate yourself. So here is an exercise I want to be able to do with you, is that I pass my key to you and see if you can connect to it. Or if you have an established account already with DigitalOcean or Amazon Web Services, I suggest that you please start machines like this and hook it up with your own keys connecting to those machines out there. So what do you want to have? Do you have? How many of you do not have an account yet on DO, on DigitalOcean?
Not good.
So the question was. My question was, how many of you do not? And I did not have an answer.
I do not have.
And you can connect my computer. Anil,
You,
I think, Anil, please mute. Okay, good. I think Mehul, thank you for muting Anil. Anil, whenever Anil speaks, it causes echo. So Mehul muted Anil, which is nice. Please don't mute me. You can probably mute me also, so don't mute me. Thank you.
I don't have an account either. Not yet.
If you do not have an account, you are welcome to connect to my accounts through the key that I have. And so I have two keys. I'm going to pass them to you. And the easiest way for me to pass the key is through Slack. I'll just drop it in Slack. You grab the key from there, and then you can use it with these machines just like that. Now, for you to use the key itself, you have to do a copy and paste. I'll walk you through how you would do that in this. This virtual machine is different from your Slack machine. Your Slack machine is probably a real computer. This virtual machine is not real. It doesn't have Slack installed. So one idea would be to go to, let me find a best way, easiest way for me to pass my private key to you. Let me find that. What would be the best way? Best way would be email, I guess. So in this file, I have these two keys. I'm going to pass the private key ID RSA and the two keys there. I'm going to pass these two keys to you.
A more secure method would be email with a one-time use password.
Yeah, at the end of the day, this is an exercise in academic nature. So we are not worried about security way too much. So if something goes wrong, at the end of the day, I can just delete these two machines and I'm done. So that's not a big deal. So security is not a big deal right now because it's more of an experimentation that we are doing. So what I'm going to do is see if I can email you these two keys. So I'm going to go to my Gmail and see if I can connect to it. I think I'm not logged in. I'm going to log into my Gmail. And send you that password incorrect. If you have an account already with DigitalOcean or something like that, please start a machine and use your own key. Don't look for my key. The way I'm for those who do not have a method of creating a machine in the cloud is where I'm sending these keys to you. And so Anil needs a key, and who else needs this? I think you need, John, you said you needed a key from me. So I'm passing these keys to you guys. So Anil gets the key, and John. Who else needs a key from this computer? If you need a key from me, this different key, please tell me that you need it so I can email it to you. I see some of you are already trying to create your own keys, which is nice. And so I have sent the key that I have to two of you. John and Anil should have my key now in your inbox. You should have that already. Let's see what other folks are doing right now. I'm going to watch.
It's not in my inbox.
Yeah, you have an email problem going on. So I think we have to figure that one out.
Okay.
I think if you can share your inbox with me, there should be a way to find it. The way I would like to look at is the email that I send to you, probably go to the update tab, not in the inbox. That's where I think you should go and look for my emails. So my emails should reach you, but in the update tab or the social tab.
Oh,
Do you know these
okay.
tabs? Are you familiar with these tabs, John?
Yeah, let me check.
Yeah, try, give it a shot. There is a separate tab. There are 4 different tabs in Gmail. I'll show you what they look like in my inbox. In my inbox, you will see that I'm showing you my inbox right now. I have this Google tab, the social tab, the promotion tab, the updates tab, and the forums tab. You should look for these tabs, and that's where you should find emails coming from me. Or if not, you probably mark me as a spammer, which means they're going to the spam folder.
Oh,
So
yeah, I see it now.
What do you see?
In the socials tab.
In the social tab, that's where my emails go. So if you look at invitations to Hangout, they probably go to the social tab. So you go to the social tab, that's where you will find the Hangout invitations.
Yeah, I see that.
Yeah, and so as simple as that. The other tabs will show you what things are from other people and other types of senders. Like this Google Hangout is a social activity, so it is categorized in form of a social activity, right? So I see that Jared is preparing a machine in the DigitalOcean. He was doing that. Who was doing what? We see Kiran, but we don't see your desktop, Kiran. We see Matt. Matt is hiding. Mehul is hiding.
Yeah.
Hey, Mehul, can you hear me?
Yeah, I can hear you.
Okay. Are you familiar with this concept already? I think some of you, some of these concepts are probably very well known to you, I suspect. Is that right, Mehul?
Yeah, most of stuff I already.
Yeah.
Hey Neelish, how do I view the keys again? Once I create the keys, how do I see them again? What the actual key is?
The key is visible to you in your .ssh folder. Something like this is what you would do: is you go to the terminal and go to the. Let me clear it. So on my computer, you should see that I'm in the home folder. Then I go to the .ssh folder, and that's where I see the key.
Okay, let me try that.
Nilesh, can you send me the key in an email to me?
To Kiran also?
Yes, please.
Okay, I will do that. So I'm going to forward that same email to you, and you should have it. And that contains the private key that I'm forwarding to Kiran. Kiran, RKT, email.com. Yeah, please check if you got it.
Yeah, I got it.
We have Jared, I think, playing around. I would like to suggest Jared go to distribution tab. Go to the distributions tab, not your application tab. So you're on the application tab in image. Go to distributions and select Ubuntu. And go down. Yep, that's how you go. So scroll down, add your key there, and so click the add key button. Click the add key, and then paste your key there in that window. Paste it. So you grab your key and paste it in that window.
What key am I putting in there?
You have to generate your own key and then paste it. You saw me generate key, did you? SSH keygen.
SS. Oh yeah.
Yeah, SSH keygen will generate a key in the .ssh folder in your working box. You can also open the terminal and do it there.
Okay.
So go to the terminal. That's where you should be able to find your SSH keygen command. You run it there, and it will create the key pair, and then you stick to your .ssh folder. Will have your public key. Copy that public key. Go to DO. Give them the public key.
SSH
dash keygen. Key generation. Yeah.
Okay.
And so yeah, just enter will generate the key pair for you. Enter, enter, and enter.
Once it's generated, Neelish, how do I view it now? How do I view the key string?
Okay, you view it like this on my screen. Cat. Okay, hold on. I think I have go back to here and say cat. Okay, come on. Hold on. Let me show you a different way. So here you say something like this. Cat /.ssh id rsa.pub. That's how you view. So that's the command. I don't have that file in this particular terminal, but that's the command to do it. So I'll type that command one more time in a different, bigger screen.
What's the IP address of the machine?
The IP address of my machines in San Francisco as well as in Germany are in the email. I'm going to show them to you again. How are you doing? Yep, that's exactly how you do it. So you added your private key, a public key into that location, and then you add the key. If I click the add button, and it will add a key for you. And it is probably added already. You have to give it a name on the top. There is a name location. Add. There we go. User at workstation added. And so at this moment, you select that key, and then you choose a host name. At the very top, you have to have a name for your machine. At the very top of the screen, there is a place to add a name. Got it?
Uh-huh.
At the top, you have to add a name.
Okay.
At the very top.
Oh, okay, okay.
You have to give it a name, and then it start a machine for you. Yeah, just no commas, no dashes. So it's very strict about that. It's a host name. You cannot have commas and dashes and periods and things like that. So just one word is good.
Okay. And then enter.
Yep.
So interesting. So I was not, I couldn't get the VirtualBox ready, so I had another Ubuntu OS. I connected directly from that machine, and it gives me a warning saying that your private key file is
too open.
Too open.
Too open. Yeah, the idea, I'll describe that idea. So what happens is, I told you when the file got created, it has to have a permission of read only and write only by you, nobody else. And right now, when I emailed it to you, the permission got lost. You have to set the permission to be such that only you can read and write, and then it will work. So the way to set proper permissions is to actually do a chmod, like chmod 400 followed by different, and that will set the right permissions for you. And when you do that, you should be able to then connect to your machine using the key that you have. That should work in that case. You see what I'm saying?
Yep.
So if you understand chmod, that should be okay. If not, I'll explain it further.
Damn.
So when you want to do a chmod on your file, what would you do is you run something like this on the terminal. You want to make it big so you can see it properly, and you do a chmod 400 followed by the file name statement, and that should do it. That would set the permissions of the file so that only you can read and write, nobody else can. This is how you limit the permission, the scope. It is not too open, and then it will allow you to connect.
400 is only read, right? It doesn't do W.
Yeah, 400 read is okay. You don't have to modify the key, can you? Or are you? You can do a 600. That's also okay.
Yeah, now I'm able to log in.
Yeah, you should be able to successfully log into a remote computer, no problem, if the permissions are set correctly. The private key has to be kept safe, and if the permissions are too open, anybody can read, it will not let you use that key.
So it ignored the key, and it asked for the password for root when the permissions were not set right.
Exactly. Because it is not going to, it refuses the key, right? It doesn't recognize the key and it asks for a password. But I don't have a password to give you. I mean, I never created one. There is no password to the machine at all. How are we going with this idea?
Right.
Now, if you look at, if you want a little bit more time on this, we can do that. Otherwise, we'll switch to the next topic, which is how other companies deal with this problem of keys. There are some other methods where some other providers and companies deal with the same key management problem in a slightly different fashion. It's their own way of doing it. I'll illustrate that idea also in just a few, as soon as you're ready. How are you doing, Anthony?
Good.
Did it work? Did you try? Give it a shot?
Yeah, I got it.
Did it connect nicely? Good deal. Which screen is that? That is Jared, I think.
Yeah, it froze and then.
So Jared, you are on a Windows machine, are you? Which computer am I looking at right now?
I'm on Safari for this one.
So that was Anthony's screen. Okay, I see. And Safari, you are creating your droplet. Yeah. Did you choose San Francisco again?
Yeah.
Okay, try not San Francisco because I have had this problem with San Francisco for the last couple of days. I'm noticing that they are slow.
Okay. Yeah, because my application's not responding.
That may be another issue. Yeah. Try a different browser, Chrome or something.
Oh, okay.
Don't try this Safari. I think you had a problem with some other the other day.
So.
Try that one. So Anthony, it looks like it's working for you, right?
Yes.
Okay, good. Let us try the other idea, which is this concept of key generation. The other topic that I'm on the same topic of key generation is another method that some companies apply. Is that they want to make it even simpler for users, and what they do is they just give you a key. And so that's what I'm going to show you now. Is this company called Amazon Web Services that I think you may have an account already by now because they're giving you a link that I gave you last time. Amazon Web Services gives you an account for free for first year. So grab that link, and when you are in the account, you should be able to find this screen, which is the console that Amazon provides. And as we discussed the first day when we met, we discussed about infrastructure as a service, platform as a service, and infrastructure, platform, and software as a service. The concept that I'm essentially getting into is beginning to understand and explore what types of infrastructure services are available out there. We just finished experimenting with one such provider, which is DigitalOcean, and we are changing to another provider right now, which is Amazon Web Services. And what they provide is a whole host of services. We'll begin with focusing on their infrastructure as a service, which is the Elastic Compute Cloud, ECC, or in short, they call it EC2, the same thing, and ECC, Elastic Compute Cloud. And what we see here in this scenario is that I will go to the Oregon region, which is different. So I'm going to go to the region closest to me. And in the Oregon region, I have basically nothing running in this region. But I also see that there is a word here describes that I have 2 key pairs. And so if you look at that key pair segment, it will show you that there is a place to generate your own keys without having to run SSH-keygen. Like this SSH keygen is not available on Windows machines. And so how do you make it easy for users for them to be able to connect without forcing them to generate a key pair is the idea that Amazon has. And what they do is they let you create your own key pairs on the website. So on their website, if you go scroll in the upper orange colored box, and that's where you'll find a list of all the services. And in that orange box, if you click on the EC2 section, which is the Elastic Compute Cloud section here, and then scroll to the bottom where you'll find the word key pair. That is a button which will let you generate a key pair by a click. So you click the blue button up on top, and it will generate a key pair. It'll ask you for a name. So I'm going to give it the name. I'm going to call it, let's call it Anthony, just for fun. And instead of ID underscore RSA or instead of different, I'm going to call it Anthony. It doesn't really matter. And I'm going to create the key. Now, what do you think is happening on the backside? What is Amazon doing at that moment when I click the button? What do you think they're doing?
Running the code we just ran.
That's
Running
exactly.
SS keygen.
Exactly. They ran SSH keygen, and by the way, they just dropped the file, the private key file, onto our laptop. That's what they did just now. So they just dropped that file in my laptop and said, hey, here is your key. Okay. And so I'm going to save it somewhere, safe, in the download section. So save it. And so now I have the downloaded, the Anthony private key. But we are discussing about a key pair, right? A pair combination. There are 2 things. Where is the second object, the public key? Where is that?
That's on the machine already.
They gave us the private key. They just dropped a private key in our downloads folder. And so this downloads folder that we have, this one, contains the anthony.pem, which is a private file. Right? It is not the public key. It is the private key. So where is the public key?
You can not save it locally.
They did not give us, they do not give us. They just keep it with themselves. Just like in case of DigitalOcean, we gave it to them and they kept it in the DigitalOcean account. If you remember, in the DigitalOcean account, we log in and we were able to provide our key to them, and they had our key right there in the security settings area. That's where they have kept our key, right here, DO. In case of Amazon, they kept the key right here, which is called Anthony. And so they chose to not give us the public key. That's their choice. And it is fine. It is totally okay. They gave us a private key and we have it. We have it in our in a downloads folder somewhere kept safe. And that is understood. However, the question that comes down is, do you trust them? Do you trust them to not keep the private key for themselves?
No.
That's the real question. So what do you think? Do you trust them?
No.
No chance.
Yeah, it's totally your choice, right? Trust is a very subjective thing. So it's totally up to you. If you trust them, then you use this method, the blue button, to create a key pair and have them create a key pair for you. And then you get the private key downloaded and have them keep the public key, and you assume that the engineers that wrote that code at the back end are not keeping, not cheating, and not keeping the private key copy with them as well. That's the assumption. And I think it's a fair assumption that they're not keeping the private key for themselves. As soon as you click the blue button and it creates a key, they just download the key, dump it on your laptop, desktop, and you just get the private key. And we safely assume, and it's okay to assume, I think, that they are not keeping a copy of the private key with themselves. Which is, if they do, that's going to be a security hole, a big one, a really big one, right?
Right.
And the private key is bigger than that fingerprint, correct?
Correct. The public key is smaller, the private key is bigger, and we just downloaded the public key, the private key right now on our laptop. We can go and see it. So I'm going to go to the downloads folder, and we have the Anthony.pem right there. And so this is the private key we just got from Amazon. And they have kept the public key themselves. What does that mean? Is that we can use this. By the way, these key permissions are kind of too open. And so you have to still set the permissions for this key correctly. Meaning, you have to do a chmod 600 and then Anthony.pem. And then the permissions will change to, clear permissions will change to RW and only for you. And so you're narrowing down the scope of permissions by doing a chmod like this. Now, having done that, we can now use this private key to connect to a machine in Amazon. You cannot use this key to connect to a DigitalOcean droplet, can you?
No.
No. DigitalOcean has no idea what you're doing. It will not let you use this key and get in. It doesn't work. Any machine you create needs to be created with this key, the public key to begin with. If you don't do that, you cannot get in. You have to go back to EC2 dashboard and then create a computer, and this is a slightly more involved process, but I will show you that. The reason I begin with DigitalOcean is that it is, I think, the simplest way to create a machine in the cloud. It is very, very visual, very simple, step by step. Give it a name, select the size, select a region, and don't select San Francisco for right now. Select a key, and off you go. So one flow sequence, very easy, very simple. I think this is one of the most beautiful implementations of a user interface, and I love it. That's why I begin with this example. But then we don't really care which company we work with, because at the end of the day, it's a machine. And we are going to use open source tools, like in the second segment, we'll begin using open source tools, Chef to be specific, to play with these infrastructure and create something of meaning to us. As we proceed in that direction, these are some primitive beginning steps that we need to understand. What are we really building is infrastructure for services deployment that we will deploy our own things, our own applications on top of. And these are some basic steps we need to be able to understand and do. And so right now, we'll now switch to Amazon Elastic Cloud ECC or EC2. In here, the same process is a little different, but the concept is very same. Very, very similar. We'll click on the blue button, which is to launch an instance. As you will notice, they call it an instance as opposed to a droplet, as opposed to a server, as opposed to a machine, as opposed to whatever. But it's a machine. It's a virtual machine that you get in their cloud. So we're going to click the blue button, and it will ask you a set of questions. Multiple pages, as opposed to just one page in DO. Multiple pages. Here you get to select which operating system you want. And so I'm going to select the operating system, say Ubuntu. And then select a size. What size do I want? And since we are a free tier account right now, first tier is free, select this T2 Micro. It's going to be free for you. So select that general purpose T2 Micro machine. It has 1 CPU, 1 GB of RAM, and it's good enough for a test. We'll begin that and configure some instance details. In here, you will notice that you have a choice of selecting a virtual private cloud. And since most of you have new accounts, you do not have the other option. which is to launch an EC2 Classic. My account is probably 8 years old, so I have that account. That option is gone for new people since 2010. Once you select a VPC, you also need to select a subnet, one of the subnets that you select, so that the machine will get created in that subnet. You also need to remember to auto-assign a public IP address so that you can easily connect to it. And when you do that, you enable the auto-assignment of IP address, so you click the Enable button. You get that? Now we'll jump to the next screen, in which we'll add some hard disk to it. So we'll go click on the Add Storage button at the bottom. And next, we'll select some space, some hard disk space. And I think 8 GB is good enough for a quick test. We'll leave it alone, not change anything, 8 GB SSD. And then we review and launch. In that step, it is telling us that your security groups are open to the world. And what does that mean? The security group idea is something that I would like to describe to you. It is, in concept, the same concept that you think of as a firewall. And so, since this is giving us a warning that your security group is too open and too wide to the world, I would like to create a new group and call it Cloud Genius. And this Cloud Genius group will regulate our permissions very, very diligently, very carefully. And how do we do that? We allow only certain protocols, only certain ports from only certain IP addresses, and everything else is logged out. So right now, I'm going to add a rule to allow SSH protocol, like this, and select the source where I can connect only from my IP address. And so only me from this computer can connect to that machine that is getting created, because this IP address has to be this, is the rule that I'm putting in place. And when I do that, only I can, from this machine in my location, in the office, I can connect to that computer that I'm getting, that is getting created in the Amazon cloud. It will be limiting, very, very narrowly focused. Only I can connect because of the rule that I'm putting in, which is a security group setting that I'm adding right now. When I do that, it asks me to review and launch. So I review it. I have a T2 micro machine, 1 CPU, 1 GB RAM, and my security groups are set so that only I can connect to it through my own office location from this port number 22 through SSH protocol, and nobody else from anywhere else. So that's the rule I'm putting in, and then I will launch the machine. When I begin to launch the machine, it says, you know what, you should include a key pair. If you do not include a key pair, you cannot connect to it. And I said, yeah, I understand. And so I have to select a key pair. I'll select the Anthony key pair, that one. And then I acknowledge that I have the private key for it. Otherwise, you know, without the private key, I cannot connect to it. So what's the point of starting a machine? And so now I have acknowledged that I have the corresponding private key to this key pair called Anthony, and it is safe in my laptop somewhere. And so I can then launch the instance. The instance gets started, and in a few minutes, it is a little slower, and we are going T2 micro, so it's a cheaper machine. But it has given us certain characteristics of the machine already. For example, it has given us a public IP address. And using that IP address, we should be able to connect to it as soon as the instance state is ready and available and active. Right now, it is not. It is pending, and you can see that the instance state is pending. The status checks are initializing, and as soon as the status checks are all green, both the checks, we should be able to then connect to this public IP that we now have. So in our scenario, we should be able to grab that public IP from here, copy it, go to our terminal, and construct a command which is very, very similar to before, which is SSH-I. And can you tell me what will be the location for the Anthony.pem file, the private key? It is in the downloads folder, and we are in the downloads folder, right?
Mm-hmm.
It is sitting right there. So we can just say anthony.pym. And then in case of Amazon, the username is slightly different. It is not root. Like in case of DigitalOcean, it was root. In this case, it is not root. In this case, they have chosen to use the word Ubuntu as the user, followed by IP address. So we need to type the IP address right there. And then when the machines are ready, we should be able to just connect to them. So let's see what the machines are doing. It is initializing, as we see on the back screen. It's still initializing, and we'll give it a few. As soon as the machine is ready, and all ready and ready to go, we should be able to connect to it from this command as soon as that thing gets ready. Now, while it gets ready, I would like to now discuss this concept of what is called a security group. And we just briefly referred to it, but I would like to go deeper into that and help you understand how and in what cases are security groups tremendously useful in very easily securing your infrastructure in a virtual private cloud. And that's the discussion I want to have while this machine gets initialized. We'll come back to this and connect to it when the machine gets ready. So I'm starting my whiteboard. In that whiteboard, you should be able to see my writing. And I'm going to describe this concept that I just told you briefly about, which is this idea of what is known as a virtual private cloud. Now, can you please tell me, what do you think of VPC when you have this idea of somebody is using a VPC? What does that mean? Anybody?
Private connection.
Or what? Sorry?
It's a private end-to-end connection.
Yes, indeed. So the scenario would be conceptually similar to your home. You have your home, and you have your company that gives you internet. That is, say, for example, Comcast or somebody like that. Inside your home, you have lots of machines like iPads and iPhones and Androids and this and that, and, laptops, desktops, multiple Xboxes, PlayStations. All these devices inside your home have what is called a RFC 1918 or private address. So it's a 192.168. something, or it's a 172. something, or it's a 10. something. Some address in this space is considered a private IP address. It's kind of, think of it as only inside your home. Now imagine the same scenario, and you put in the public cloud a little home for yourself. And inside that home, you have your private space and all the private IP addresses. And somebody is giving you connection from outside. And that could be Amazon, that could be somebody else that gives you a connection. But all things inside that area are isolated from anything outside that. And this is very similar to you using a router in your home. So you have a router, like, what's the router called? Netgear, I think you use, Kiran, I think you have a Nighthawk Netgear router.
Yeah.
Is that right?
Yes.
So that router, essentially what it does is, from your external IP address provider in Hyderabad, you have a company in Hyderabad, I don't know which company is going to give you a public IP. And inside your home, you have this Nighthawk, the router, Netgear. That Netgear router is connected to a modem, and the modem is then connected to Netgear, and then this Netgear is what gives you internal machines, IP addresses that are internal to your home location. So similar to that setup is what you would need to have in a private cloud, where a private cloud provider, like say Amazon, will give you an infrastructure in which you can have individual machines inside your VPC, any number of them. There is a limit to it, and all these guys will have a private IP address, and they will have no connection to the outside world at all whatsoever. And if that's the case, how do you connect to it? That becomes a challenge. So we'll discuss that and think of ways to work around and things like that. But for right now, that's the quick and dirty concept of a VPC. Now, if you cannot get to it, can I connect to a computer in your home sitting right here? Probably not, unless you let me in. And how do you let me in? Is a question I have. So you can either open up a port and let me come inside through your Netgear router, and then I can give you your home IP address and open up a port here so I can enter from that port, and then from that port through and through your Netgear box reach your laptop, right? So your laptop, I can go like this, only if you allow me to enter from your firewall. Enter through your firewall and through that go to your laptop. If you allow that scenario, I can actually connect to your laptop. And that's one mode of connecting. The other mode of connecting in the case of a VPC is that you could, each machine inside your VPC, you can have them have a public IP as well as a private IP. If that's the case, you can connect directly to any machine. If it has a public IP, you can connect straight directly to it. If you do not have this method, there is no way to connect it directly. Then you have to go through what is known as a jump box. A box that will let you take a jump step. And so you will deploy a jump box which will have a public IP, so you can get in. And this jump box has a private IP, and that is on the same subnet which has your other machine sitting right there. And so you come from outside, get inside through the public IP address into the jump box, and through that jump box that you go in wherever you want. And that is the scenario that I will illustrate to you. If you go back to our machines, it is now running currently and it is successfully checked. You will notice that the machine I created has a public IP address. It also has a private IP address, by the way. You notice that it has a 172 private IP and a 54.200 public IP. So you notice that the machine that I just created has both. It is directly has a public location as well as a private location. So in our case, we have a 54 dot address and a 172 address, which is internal. Think of it as a Ethernet number 1 and this is the Ethernet number 0. We have two NIC cards, think of it that way, and the machine is connected both to public internet as well as your internal subnet that is available only to you within your private cloud. So this subnet is mapping and spanning your internal cloud, whereas this machine has another connection that is publicly available, so you can connect to it directly. Let's try that if it actually works. I'm going to my terminal, and I see that the machine that I have created is actually running. So I'm going to type that same command, which is ssh-i anthony.pem ubuntu at IP address, and I will get the same question that we had before. Do you know what you're doing? And the answer is yes. And we can go ahead and add it to my list of known hosts. And then I am connected to the Amazon machine with a private IP address of 172.30.0226, which is the same address that you will see here in the 172.30.0226, the private IP for that same computer. So we were able to connect to that same computer and are able to actually check the characteristics of the network right there. You have an internal IP address showing up here, and a localhost adapter showing up here, and this IP address also has a corresponding public address through which we came in. We came in like this, and that's how we entered the machine. Now, having discussed this, let's discuss this idea that I was further exploring in the context of a VPC. if you go and create a VPC, it is very, very easy. And if you start the wizard, there are 3 or 4 different types of VPCs that you can have. One of the types is illustrated in this example, which is all the machines that you have are in your private subnet, but they can connect to the world outside. I think somebody's. Are you guys having issues with the Hangout? Somebody's pinging me on Slack.
Oh.
Nope.
No issue.
I see select VPC configuration.
Okay, good. Then that is exactly what I'm showing. Is there are 4 different methods of designing a virtual private cloud for you, and so that's the first example right now. And I think it is Jared that is having an issue, so I'm going to invite him again. So just stand by. I'll invite Jared.
I'm in right now. My connection's just off.
The connection is just off means what? What does that mean? Meaning you're not able to see me, or not able to hear me, or what?
I can hear you. I just can't see you because my. I think it might just be my computer connecting.
Yeah, I said rebooting your computer. Come through Google Chrome, check your Gmail for a link, and connect again. Okay.
Okay.
So back on this discussion about a single VPC. The idea here that you have is all these machines are essentially connected to the internal network inside your public subnet that you see in the picture here. And also can connect, don't have to, but can connect to the world outside. Meaning you can get in. So if you happen to have a scenario like that, in which you have all the machines inside a contained environment, and all these machines are sitting here, and some of these machines actually have a public IP address, so they can go out to the internet. And sitting on this machine, you can go to CNN.com. I don't know why would you do that, but you can. You can go download updates to Windows, to apt-get from Ubuntu, and basically connect to something like a simple queue service, or Amazon S3, or other external properties that you might have away from here. As long as you have a public address that is available to you on any one of these machines, you can then go out and reach out on other things on the internet. If that is not available, there is no way to connect in this model. In this scenario, you cannot. So that's the scenario here, which is everything in one box, everything in one virtual private cloud, one public subnet that has a capability to get a public IP address if and when you want it to have. Which means you go back here and select and start a machine like this, and in here you will find that it will let you select that configuration which I am describing. So go back previous, cancel, do it again. Launch an instance, select an OS, and review configuration instances, and this is where you will find the detail. Here you can select which subnet I want. There are 3 choices. And among these 3 choices, you get to select whether I want my public address available or not. If I disable the auto-assign public address, I will not get outside usage, which means I cannot go out. My machines cannot update themselves, which will be a problem. You have to find another way to solve it. So if you forget this setting, you will be at loss if you just have one machine. You can do nothing about it. However, if you keep it enabled, you will get a public IP address like I got in this other example, which is running right now. And in that one running instance, you see that this machine has this public IP address. And we just connected to it comfortably, no problem. So that was the scenario regarding setting up a VPC in the context of what we were discussing, which is the first example, which is put everything in one container, one VPC, and have everything all in that one subnet. And selectively, some machines will be able to connect outside and are visible on the public internet. Let's look at another example. So click this, and a slightly different picture emerges. In here, there are 2 types of subnet. One that is just not capable of connecting to anything outside. It is purely internal. This is private subnet. That's what you see in this picture at the corner. You have the private subnet in this section, which is strictly focused on only the internal IP address space. It is a private subnet. Only internal machines can be accessed from machines within it, and nothing else, nothing outside. So that was this small little square at the left, on the right side. On the same picture, you see the other scenario, which is a public subnet, where you have machines that not only have a private IP address, but also have the ability to connect outside. And through them, you can then reach out to internet or do other things. And that's a combination scenario where you have a public subnet and a private subnet combined together. And each of these machines then, in turn, are sitting inside your private cloud. Now, a question for you. How do you think these machines can actually update themselves? How do you think they will be able to get app updates or Windows updates? When you have a subnet which is public, it can go out. But a subnet which is private, how do you think this subnet will reach out and update machines or do something important that needs internet connection from outside? What is needed to make machines sitting in this subnet connect to the internet? How do you actually find a way for them to connect? The public guys can connect directly, but these guys cannot. So what is needed for these guys to go and connect to the public internet?
Some kind of router or jump box. I mean, something between the public and the private, right?
Put a router right there. And the router is just like what you put in your home. This guy will give you IP addresses to your internal boxes, and this connects to the world outside. And this actually is another box sitting right here. So in simple redrawing the diagram, in your private subnet as well as your public subnet, you will have one of these boxes in the public subnet, and this is the private subnet. One of these boxes in the public subnet needs to be a NAT, or network address translator, or a router. So one of these boxes needs to be a Netgear. I'm just saying Netgear as an example. That's not what you do. In a real scenario, you would actually put a Ubuntu box or a Red Hat box or some Amazon Linux box that acts as a Netgear. You will do that network address translation for these boxes internal to your private LAN, a private subnet. Like that. And this, in turn, can connect to the internet outside from the external interface. So you will have a machine dedicated for this purpose. And that function of that box will be specifically to allow these guys to connect through and through to the world outside. So when you have a scenario, when you have these internal machines connect to that NAT or the router box, and this in turn goes outside, what NAT essentially does is every packet that originates from here, it is actually doing what is known as a masquerading. It pretends that, hey, it is generating the traffic, whereas it is not. It masquerades as if, this guy sends a packet out to the internet, it gets routed to the NAT, and NAT says, you know what, I am sending it, take it. And so the other guys, other machines will take that packet and in return give a response. And NAT is stateful, it understands who actually originated it, so it gives that packet response back to the same guy who generated that request. And if a new guy sends another request to NAT, it will masquerade again and then send the request out to the other computer or other IP address somewhere out there in the internet, and a response coming back will again go back to this guy, not the other guys. It knows where it came from, and it is stateful and understand and smart enough to know where the machine traffic needs to go back when it does. That's how your router works. That's how an ad box will work in the cloud. So if you select this scenario, which is where you are creating two subnets essentially in a VPC, you will have a private subnet and a public subnet together. There are two more examples of VPC, which are this one. And this is a very, very common scenario used in most companies. This is how most companies will deploy a private cloud, which is you will have something very similar to what we just discussed. But in addition to that, you have a dedicated VPN connection from your corporate data center that has a basically it belongs to the same subnet that you have. So you become, take this private subnet that you have outside in the VPC, make it a family member in your company. Think of it that way. So the entire private subnet, bring them home to your data center. And so it is your extension of your data center. It is the same idea we discussed the last time, where you can deploy this concept of bursting, where you have, year-round your data center that you have is servicing your customers from January through December. But come day after Thanksgiving, your demand grows up, and during Thanksgiving through Christmas, this traffic is higher. So you want to expand and breathe into the public cloud. You want to burst into the public cloud, and you will do something very similar to this, where you take on more load and add more private subnet instances. They become a part of your overall infrastructure, and you are able to service more customers by expanding what you have using the private cloud scenario. And so this is an established connection between a VPN connection. So you will deploy something like what is that? OpenVPN software, and this is a beautiful open source VPN software that is available in all Linux distributions. And what you can do is use this to dedicate this connection between your data center and your virtual private cloud, the private subnet. The private subnet that you have, you make a VPN connection between your data center, and the private subnet essentially becomes a part of your data center virtually, even though it may be away from you and you don't even know where it actually sits, but it doesn't matter. And that's how you will establish this VPN connection. And that's the scenario where you either use this open VPN method, or you can use Cisco, Juniper, and a bunch of other companies have VPN solutions. You can use any one of those and establish that connectivity. And if you have an established VPN method, you can, these companies will allow you to use your existing VPN solution, and they charge you a little bit extra for that. So just so you remember that there is a cost to this VPN business. But that VPN essentially becomes a part of your data center effectively. So that's the third scenario. There's a fourth one, in which some companies want to actually run just computing, and they don't want to service something else outside, but they have customers only inside. So internal customers. And you still need some horsepower, some CPU consumption that you want to expand because of internal processing or some other usage in the company, and you need more resources. You can deploy a strictly private subnet out on the cloud in a VPC setting and hook it up through VPN, and nothing goes outside. This is classic of companies like Boeing, for example. And we have a Boeing employees. We have, by the way, Matt. If you haven't met, Matt just joined. He's a Boeing employee. John used to be in Boeing. So companies like Boeing prefer this scenario a whole lot because they are secretive about their operations. They don't want connections outside, and so that's the context where we have a corporate data center directly hooking up to a private cloud through a VPN method established, and there is no method at all whatsoever to connect to something outside. Got it? Question.
Nope, I'm just gonna have to go over that again. Watch the video again.
Yep. I think that's fair, and I'll elaborate it further if you need, and I'll prepare more content for you to be able to access. I just want to point out that there is new content available for you to review, and that is available here for in another browser. I'll open it up. You probably have access to it already, and this site is called online.cloudgenie.us. On that site, you log in and you go to the Cloud Technologies segment. And in there, you go to Courseware tab, and that's where you will find most of our discussion today, which is making secure connections. And how do you establish secure connections? What do you need to make I think I dropped my display, got disconnected. Let me connect the display again. Display there. So I'm sharing my display again. And what do you need to create a key pair? How do you share your public key with the cloud providers? How do you connect to a remote computer? How do you actually understand and disambiguate between known hosts and authorized keys? And there are simple, short, 2-minute videos on every topic that you can see here. And then this question of MD5 validation. There are some videos here for you already. What I would like to now do is illustrate to you this example of a VPC and what it actually does. But before that, I would like to ask you some questions, which are, what do you think about this VPC business? Where do you see it useful in your context? How can you apply this to some real life scenario? How would you use these things? The 4 examples. I want to hear your thoughts on where would you put such thing to use. Right? We have these 4 examples of a single VPC. Connected everything as you need on the internet. Second one was this, which is keep a private subnet, public subnet. Third one was keep the private subnet connected to your data center. And fourth one, don't connect anything outside whatsoever. Keep everything private. 4 scenarios.
Nilesh, we don't see your screen being shared.
Oh, screen sharing.
So, just see your fabulous visage.
I know. The screen sharing somehow drops by itself for no reason without telling me. And so I'm going to share again. And
we're here to tell you.
Yeah. So I was describing those 4 scenarios, VPN connectivity. So the questions I have for you is, where do you see these things when you can put them to use in real life?
Yeah, well, I have a customer that's already using that last option. The VPC, private subnet, and hardware VPN, as they have 100% of their computers are now in the cloud. The only thing they have is laptops in their production data center. They just use laptops. Everything else is up in the cloud. The third one I have is the third choice, the one with hardware VPN.
Mm-hmm.
Actually, no, my apologies. The first one. The first VPC. It's a very simple one, and that's used in my own lab, so we can connect to S3. And I'm doing a project now, Nilesh, thank you very much, which is, I'm glad you mentioned the OpenVPN, because the third option on the left with hardware VPN access is so we can demonstrate doing full system high availability. That's taking a production machine, taking a snapshot image of it, and copying that up to the cloud so that an EC2 instance is a standby. Something happens in their production environment, the Amazon EC2 instance stands in. So that's the third one we're looking at. So there's a project on number 3 for me.
Nice. That's awesome to hear. Awesome to hear. I would like to also point out one key difference that is kind of not super obvious in what you see in the first scenario, and compare this with what you see in the DigitalOcean scenario. Right? In DigitalOcean, you have this concept of a private networking choice is available, right?
Right.
And so I would like to understand from you first, what is that private networking scenario that you see here. And so you create a machine here, call it, give it some name, whatever, some name, and then select a size, and then don't select San Francisco, select Frankfurt, and you select private networking. And what are we really getting when we say create a droplet, and how is that different from this scenario? That's the question I have, and then I'll tell you what's going on behind the scenes as to what are the key differences in between this scenario number 1 in Amazon and the DigitalOcean private networking option, which apparently is very similar. So you see in DO versus Amazon, you have a VPC which can connect to public and connect to private. And DO, you get a machine which has a public and also has a private option, right? There's a choice there, private choice, private. What was the name again? Private networking. So this compared to this, what is the difference? You got a box here, you got a box there. So it's public, private. What's the difference? That's the question. You tell me what's the difference.
With a private one, in DigitalOcean, all the droplets you create, if you select private networking, they can communicate with each other. Perhaps even shared private networking. But it means they have no public access.
Right. The point I think you're trying to illustrate is that this case of DigitalOcean private networking versus Amazon private networking, there is a huge amount of difference that is not super obvious to most people.
No.
And that is as simple as this. Imagine if they claim that they have private networking, all it means is that they have an IP address space that is apparently in the range of 172 or 192 or a 10 dot address, but it is like sharing your home network with your neighbor.
Right.
That is what DO does, which is a bad idea. I mean, that's how it is. Understand that this private network does not give you isolation, does not give you any security whatsoever. What does that mean? It means that you have to worry about. It basically means you get a droplet, and you get a machine in EC2. You get a public and you get public IP address. That's good. You get public, private and private. This private is not necessarily private. You're sharing it with your neighbors. And your neighbors, you don't know. If Airbus, you are Boeing company, and Airbus could be there. That could be like right next door in your same subnet as your neighbors, and then you find that they are probably snooping you. Who knows what they're doing? And you have a Boeing machine there, and Airbus is right next door on the same private network. Whereas in case of Amazon, the difference is it is a it's a virtual private cloud, and your private subnet is truly, it is for you and only you, nobody else. That is the difference. And this is just, bad. Just remember that this is bad. Understand that this is bad. Understand that, somebody can come back door and do havoc. And how do you prevent that? That's what comes in this other concept, which is called IP tables. And IP tables are a part of Linux. They are basically the firewall, the elements that build up the firewall. And that's what you need to use. And we'll go at maybe in the second segment, we'll go in detail about how do you actually make use of the IP tables firewall rules and secure your DigitalOcean droplets. So if you have IP tables in place and appropriately structured, you can get the same amount of security from in a DO scenario as good as this scenario in VPC. In VPC, if you have a VPC, it makes it easy. You don't have to worry about IP tables. And IP tables can be hard. It can be difficult to set right. And if you make a mistake, you can lock yourself out and all that good stuff. But if you know what you're doing, you're safe. If you assume that you're safe, you're not good. Right? Questions? I don't think silence. Sorry. Mehul is quiet. Kiran is also quiet. Anil, I think, is muted.
I'm not.
No, it's all good.
Yeah, I'm just gonna have to study a little bit on it.
Yep. Makes sense. Makes sense. You review. I would like you to review and ask questions on Slack or email me or call me, whatever it takes to make you successful. My goal, as I said, is I want you to understand these aspects and put them to real life scenarios. Actually have to use these things and apply them to concepts. Apply these concepts in something or a customer of yours. Identify something that you have in mind and take that next logical step. A customer could be a client or maybe a non-profit. And if you need help with a non-profit, I can hook you up. I can hook you up if you're able to. I have tons and tons of people that need help. If that's an idea you want to do, I can connect you. Connect you with many non-profits that are requesting for help from people that are learning and applying concepts to solve somebody's problem. If you have that inclination, let me know. I'll connect you guys. I have already done many cases where people who want to get some experience, get hands-on training, and more importantly, get an endorsement. So you see that thing here, let me show you. So some of our people that graduated have received endorsement, like this guy. He worked for a non-profit. If you look at his profile, I think he has received a nice endorsement from the CEO of the non-profit he worked for. There it is. And so here, this lady, Ebony Johnson, has provided an endorsement. Oh, where is Ebony? Ebony, where did you go? There. Yeah, so Ebony has given an endorsement for a project that he did for her. And Ebony is the CEO of the Next Chapter Corporation in Washington, D.C. So like her, there are many cases where we can, have, if you're inclined that way, I can connect you with people who would love to get help from you for a good cause. Like Ebony is focused on helping women veterans. And another case we have, which is I think this gentleman, he worked for another company that, here, it's called Mo's Heroes. And this Mo's Heroes organization, what they do is help homeless veterans. And they are based in Hawaii. If you're inclined in that direction, just let me know. I can connect you. And we can make a project going for them. Like what these guys did is set up Google Apps for work. Or Google Apps for voice. You know this thing? Do you? How many of you have used this already?
Yeah.
Nope.
No. Okay. How many of you have used this thing called Office 365?
Yes.
Oh dear.
And for business though, not for consumer, not for business.
No.
Yeah.
And so what I think we're going to do next is go into detail on how do you set up. Okay, got it, Kiran, got it. So what I want to be able to do is set up something that is kind of a business scenario, help some organization in streamlining their business operations in terms of collaboration, communication, document management, email, calendar, video conferencing. Like we are doing right now, what we are doing right now is a video conferencing solution available from Google Apps. We are using that right now at this moment. for the Cloud Genius company, we use Google Apps for Work, and this Hangout is a part of that game. It is very similar to what you see in this scenario, where you have Office 365, which is a part of the overall software from Microsoft for Office collaboration. And in that case, there is this element of HD video conferencing that you see in the Office 365 Business Premium on the very right side. This HD video conferencing that you see is actually my baby. I'm not, our actual baby, meaning I created it. That piece is what you see these days. It is called Skype for Business. That is the new name starting like 2 days ago, maybe 3 days ago. And the older name was Link Software. And that is the part of Office which I have a patent on, which was previously, before that it was called Office Communicator. So that software, if you recall from older days, is when I started using it, and that is based on a patent which I think I mentioned the last time. So what I intend to do next going forward is a couple of things. First thing, do you have a domain name already? Like for example, I have this domain called, right?
Yes.
You know this domain I have, you've probably seen it, and it seems to be running at this IP address. And so similar to that, how many of you have a domain already?
Sure. But if you remember, Nilesh, mine is, I'm just squatting at the moment.
Yep, yeah, squatting is fine. What we want to be able to do is take your domain, the next logical step, which is host Google Apps for Work on your domain. Meaning, let's do something here. For example, this domain I have called mylastname.com. That's hosted on Google Apps for Work. You can Google Apps. Domain last name. And so you can do something like this. And we want to enable you to use these two services. So we are changing topics a little bit from infrastructure as a service and changing over to software as a service. And we will be using these examples, which is Google Work and Office 365. And for these to happen for your business, if you want to do this for your business, what you need is a domain that can then map itself to Office suite of applications from either Google or Amazon, or Microsoft, or both. So the scenario would be that you go to, say, drive.yourdomain.com. It will take you to Google Drive. Go to calendar.domain.com. It will take you to your company calendar. Maybe it's easier if I write. So, yeah, writing. So I'm going to say so calendar.domain.com, email.domain.com. You can have sites.domain, even whatever you want. Basically, create whatever you want. Drive.domain.com. And so on these entities or these URL endpoints, you can start and run specific services for a business. For you to be able to do these services available from two big vendors in the space today, which are Office from Microsoft and Google for Work from Google, we would like you to understand the nuances and pros and cons of how do you adjust your domain settings, your DNS settings to make it correctly work with Google Apps for Work, including things such as setting up CNAME records, setting up CNAME records, setting up A records, setting up MX records, setting up SPF records, setting up DKIM records, and there are a bunch more, like TXT records, and ton more types of records that you need to be able to modify. You do that change in your DNS control panel that you get when you have a domain, and you can then manipulate your domain and have it work with a professionally managed Office suite of applications, either from Google or from Microsoft or both. one after the other. And that entire scenario you can play for free for 30 days. I think both companies allow you to experiment with it for 30 days for free. If you scroll down, there should be a method somewhere here for plans and pricing for, I think somewhere they'll get Microsoft free trials. I'll find a free trial for you. There it is, free trial Office Premium. We'll click that free trial link and pass it on to you for your in your Slack. I'll pass that link for you. In Google also there is a way to get Google Apps to work for free for 30 days, which I think is a great exercise for you. You should be able to do it. In order for you to do these exercises, you need to have a domain. You can get a domain for yourself. If you don't have one already, you can, I think, probably, let's see, the cheapest domain you can get on is probably GoDaddy domain. GoDaddy $1 domain. Let's see what we get. Yes, City is available. So there is a 99-cent domain. You know, get that. It doesn't cost you more than 99 cents, and it will help you get some fancy names that you feel proud of. And you can use this name for 1 full year. And by the way, when you try to buy this domain from GoDaddy or from other places, remember, do not repeat, do not do anything else whatsoever. Just this domain, only 99 cents, not even one more, unless there is a tax involved. So just buy this item, and they try to say a whole host of other things. Do not get any of that. Get only a domain, so you can then experiment with it and see how it hooks up to Google Apps and Office applications, and see how you can professional businesses actually run their business on these services, on these hosted services, which are available to us as software as a service. As we are changing topic a little bit, jumping over to the idea of software as a service. So essentially, we'll experiment with these two guys, Google as well as Microsoft, and play how a business will set itself up, set its employees up for collaboration, communication, sharing, and productivity improvements through use of these tools by setting it up on our own domain as an experience for an exercise that we want to be able to do the next time we meet. What do you think? Is that a good idea?
Yeah. Sounds good.
Cool. So start thinking about a name you want to buy from, say, GoDaddy for $1. By the way, you can get a domain for $15, $20, but don't buy that. Just buy this one. It's cheaper, right? Another one is 1 and 1. It's also giving you, I think, a $1 domain. 1 and 1 also gives you, let's see, what do they give? Yes, there's a 99 cents first year. And that's the choice. So, domains are available for the first full year is 99 cents only. If you like the domain, you may want to keep it for future. And at that time, I recommend going away from these guys, the 1&1s and the GoDaddies. They're not good. I mean, they're not good for long term. I would suggest going somewhere else. I'll tell you where I go, and you will laugh at it. I go to Namecheap.com. And so this is the place where you can get a domain every year, year after year, for $8 or maybe 10, but per year. So it's a very good company. The name is kind of cheap, but who cares? And so they provide you a decent service. That's what I have most of my domains located. That's what I buy them, and that's what I keep them. I have had my domains for years and years together. It's a good practice to have your domain for a simple reason. Here, have a domain that sounds like you. Like for example, the idea that we're talking about here. Have a domain that is uniquely you. So you will have something like Jared@Smingson.com. Can you get that domain? That will be a nice domain to have. But I don't know if Smingson is still available or not. Let's check. And so Smingson is likely available. You know what? Let's see. Can we get Smingson.com? Search. Available. There we go. So you can get it. Jared,
Okay, yeah. That's the one I'm picking, I guess.
yeah, you know what? Do it faster. Do it faster before I do because I can buy this and I will $1,000 or more.
Okay. There's gonna be like a bidding war now.
The bottom line is it's available. I would immediately grab it. But there's no doubt in my mind. There's no next thinking about, what should I get it or not? I mean, come on. And
Yeah.
so that's how I. And really while ago, I actually found this domain, which would have been very nice, but I did not get that. And that domain was this. That would have been just awesome.
Okay.
And so, just beautiful and awesome. And I think I slacked on it a little bit. And so there's a domain called Mac. And do you know who that guy is? Is the creator of WordPress.
Oh. Okay.
And so that guy is Matt.com, M-A-T-T. And so he created WordPress software, which is probably like 80 to 85% of sites running on the internet, including sites like New York Times and CNN. Heavily modified, but that's the guy who created open source software called WordPress. And we will use that software also again in the class extensively. That's this software. So if you have a domain, get it. So if you do not have a domain, get it. If you have a domain, take control of it and manipulate its records and connect it to a variety of services and make use of it and put that as one of the items that you have in your portfolios. It does not take more than a day for you to figure out the whole thing behind Google Apps as well as Office 365. It's not complex. It's fairly trivial to think about it. But you need to know exactly how to do each and every step to configure it right so that you can have your own jared@semington.com email, just like I have nilesh@loanday.com, for example. So you can email me at nilesh@loanday.com, but I don't use that email much because I have switched over to a business email. By the way, even loanday.com is hosted on same setup that you have with Google. So that's how we manage, that's how most companies are managing their business, their email, their calendar, their address book, their files, their sharing, the collaboration, the video chat that we're doing right now. That's how businesses have been evolving, and it is worthwhile to understand that and practice that with our own domains. And at the end of 30 days, you don't have to start paying. If you want to keep paying these companies like Google and Google and Microsoft, like I said, there is a charge to that, so you can stop paying after that. But I want you to understand these things. I want you to really go to the foundations of it, make it happen, make it complete, and then you don't have to keep paying. After 30 days, you can just let it expire. They might keep calling you, but that's okay. Right?
Right.
Yep.
Is that a good exercise? Should we do that?
Yep.
That's the exercise. All right.
So let's do it. Let's prepare for next time. Let us get a domain in our hand roll, which means going to GoDaddy and looking for a 99-cent domain. Do not spend more than 99 cents. It's a bad idea to spend money like that. If you want to waste it, don't waste it like this. If you're wasting, waste only 99 cents. If you're getting semington.com for yourself, I'll pay more than 10. But
Yeah.
don't have to. You're getting it for 99 cents. Grab it. Immediately.
Yeah, we'll
Grab
see.
it before I do.
Cool.
Grab it before I do.
I already bought it.
So did you want us to get WordPress too, or any of those you were talking about as well?
So we will deploy WordPress fairly comfortably. In fact, there is a exercise that I will point out to you in which we will use Chef to deploy WordPress in an automated fashion. This tool set called Chef from OpsCode, github.com/chef. This software that I keep mentioning about, have you heard me say that before?
Mm-hmm.
Yeah.
And so we'll use this DevOps tool to deploy a WordPress site completely, through automated method. So we'll invoke certain steps. In fact, next time we meet, we will give you a quick demo. It'll take 15 minutes for me to deploy a new machine, raw, nothing else on it. Just get a DigitalOcean droplet or an EC2 machine and invoke that prepared repository that I have against using Chef against that droplet and have a complete WordPress set up and deployed and ready to go in 15 minutes or less. It includes my talking time. So we'll do that next time we meet.
Cool.
So you'll get a few what's coming because it will help you understand where we are heading with it and give you a good understanding of how to make use of the purpose behind this entire curriculum, the program, is primarily to help you equip with what it takes to build something out there for somebody. For example, I was mentioning these nonprofits. You can actually go and hunt. I have seen people in this group who hunted for a project and completed the project and sold it. A simple thing, I sold a complete functional website. For example, this guy, the next chapter.com is a website, not this, hold on, this www. Yeah. So that site was developed by the people I mentioned, and it was given to that lady, this lady, which is Ebony, this lady CEO Ebony Johnson. So our people from this class have developed this entire site for her and have given it to her. So they made money here, and a decent amount of that. And that is something that you should think of in identifying who can get help from you in terms of a service that you will deliver to them. Create something meaningful for them. Use the tools and techniques and exercises that we are doing right now in this series, hands-on. Apply these concepts and take that next logical step, which is build something, give it to somebody, make money, put it on LinkedIn, make it visible, make it tangible for other people to understand what you can do, what you have done, and that takes that next logical step of what, I can do things, I have done things, and here's a portfolio of things I have done. It includes the tools I have used, and so it immediately gets attention. Like in the other class we have this gentleman, in the curriculum class we have on campus, we have this gentleman just told me a great story, which is this guy. I think you know him, Chris. Do you?
Yes, I do.
Yeah. So this gentleman got an interview offer from a new startup that's about to start in who they don't disclose their names, but apparently it's somebody big who is a Jeff Bezos, stronghold, like one of his direct reports from Amazon, who's now starting a new startup in Seattle, and he approached our gentleman, focused on DevOps primarily, focused on see if he can join his team to build out infrastructure for a new startup that's going to start pretty soon. And so he's excited. He's totally in the air. He's doing it. They're a little step ahead of. They're probably about a month and a half into the course, so they're doing it already, and he's super excited about what he's doing right now, which is awesome. So what other questions do you have?
Nothing else from me.
Nothing.
No.
So what I would like to see is how you are progressing in terms of the things that we did. So in this section, what we did is this. I would like you to be able to successfully create and connect to machines. This is like a basic step. You need to be able to quickly create a machine on some cloud somewhere. For example, this one, like DigitalOcean. It was fairly simple. I would like each one of you to succeed in creating droplets and connecting to them comfortably using your own keys. I would also like to have you do the similar thing with Amazon Cloud. And one little twist I will add, which is going to be a homework assignment for you. It's very simple, very, very small, but very almost a twist. The homework goes like this. You know, Amazon does not give you a public key. You understand that? You saw me that when you create a key pair in Amazon, it did not give us the public key. I want to use that same private key with DigitalOcean. Can I do that? And how? Create a public key, create a key pair from here, and in Amazon, I'll create a key pair, give it a name, I'll call it Nilesh, and then create. And it downloads the private key, and it's saved here. I have it now. Okay, good. I want to use that Nilesh key with DigitalOcean. How do I do that? That's the homework. Now, I'm not giving you estimate.
Okay.
So you don't have a public key. How do you then use it with the same key needs to be used with DigitalOcean? How do you do that? That's an open-ended homework. You need to do some Google searches and find the answer.
Okay.
And searching Google is okay. There is no such thing as cheating, right?
To use the same key as DigitalOcean?
Yes.
Okay.
Key that you generate from Amazon, you do not get the public,
Uh-huh.
you get the private, and you want to use the same exact key with DigitalOcean. How would you do that?
Okay.
And I'm leaving it open-ended deliberately because I want you to fish and hunt down the answer for yourself.
So create the key in Amazon and figure out how to use it in DigitalOcean.
That's correct. So you create a key in Amazon, you do not get the public key, and you still want to use the same exact private key with DigitalOcean or just any other company. What would it take? You need to somehow figure out a method to create a public key from a private key. And then you use that public key with DigitalOcean, and you're golden, right?
Okay.
So you have to figure out how do you create a public key if you have the private key.
Okay.
And that's a quick Google search, by the way. And the key point that I want to drive behind this assignment is to help you understand that you can create public key if you have the private key. But if you just have the public key, you cannot create the private key at all. It's not like the lock and key scenario where you have the lock and you can figure out a way to create a key and hack your way into it. That's not possible. If you just have the public key, you cannot mathematically generate the private key. Before you die, I should say. I should say before you die. Impossible. And so you cannot, in your lifespan, create the corresponding private key if you just have the public key. But the other way is possible, and it only takes few seconds. You just need to know how. And so do the Google searches and figure it out. It is, when I went to college, it used to be open book, like a long time ago, 1990. In my college in computer science, the professors allowed open book. Like, bring your books, bring the whole library if you like, and you still cannot solve the problem. And that was the case. Now, in the world today is completely different. It's, I call the open internet. Like, the whole thing is available to us, not just open book, but the whole internet is available to anybody, anytime, anywhere. So why limit ourselves? So there is no such thing as, don't search. Do whatever you like. Find a way to create a public out of a private and use that video and show me a method. Show me a screenshot that you actually connected. Post that in Slack or post that in some email. By the way, you have an email alias, an email group also. If you do not know that, I should say that. You should be able to send and receive emails if you send them to an email called, I think, thundercloud@cloudgenie.us. If you send and receive emails, everybody will receive.
Okay.
Are you receiving some emails to that email address already? I may have sent like 1 or 2, not too many, but I want to start using that email, which is like a group email for all of us, so that anybody who wants to send something quickly to everybody else in the class, in the group, you can just quickly send this to this email and everybody receives it.
On Slack?
No, not on Slack, on email.
Oh, okay.
The email alias. On Slack, it looks similar. The name Thunder Cloud is the same, but the email address is different. And I think, Kiran, that's fine. I know you can go and that's totally okay. We are going beyond our time, so I understand if you want to leave, that's okay. So what else you want to discuss?
I think I'm good, actually.
Good to hear. Good to
A
hear.
lot of info, but yeah, learning.
Yeah, I'm gonna have to review the tape.
Yep, I will make sure to stop that recording right now and make sure that you get a link to it. So I'm stopping the recording, grabbing a link to it,